Good morning. Now we are going to discuss about classical problem of synchronization, right? Last class we discussed what is synchronization, what is race condition, what is critical section. Okay, now we are going to discuss about the classical problem of synchronization. Various classical problems are used to test newly proposed synchronization schemes such as bounded buffer problem, reader-writer problem, dining philosopher problem, barbershop problem. Now we are going to discuss one problem, bounded buffer problem. There is a buffer of n slot. Each slot is capable of storing 1 unit of data. There are two processes are running, namely producer and consumer, which are operating on the buffer. The producer tried to insert data into the empty slot of the buffer. The consumer tried to remove data from filled slot in a buffer. The producer must not insert data when the buffer is full. Okay. The consumer must not remove data when the buffer is empty. See the condition. The producer must not insert data when the buffer is full. The consumer must not remove data when the buffer is empty. The producer and consumer should not insert and remove data simultaneously. When producer accessing a data, the consumer has to wait. When consumer is accessing a data, the producer has to wait. The producer and consumer should not insert and remove data simultaneously. Okay. What is the solution to the bounded buffer problem using semaphore? We will make use of three semaphore. Okay, one is the mutex M, a binary semaphore which is used to acquire and release the lock. The second one is MT, a counting semaphore whose initial value is the number of slots in the buffer. The third one is full, a counting semaphore whose initial value is 0. Okay, consider a buffer. There are two processes, producer and consumer. Initially, how many slots are empty? 6. Okay, full equal to 0. Okay, the solution to the bounded buffer problem. Okay, see already we know the condition. When producer insert a data, the consumer has to wait. When consumer remove a data, the producer has to wait. The producer and consumer should not access the buffer simultaneously. Okay, this is the condition. See, this is the simple code for producer and consumer. Okay, first wait until the buffer is empty. Okay, then it decrement empty. Okay, before insert a data, it acquire the lock. Okay, after inserting a data, it release the lock. The consumer side. Okay, the consumer has to wait until yes, the full is greater than 0, and then it decrement the full, then it acquire the lock, then remove the data from the buffer. Once it remove data from the buffer, it releases the lock. Okay, this is the example of producer and consumer problem. Okay, thank you.